So we were discussing the notations. So as we have discussed here, if this is my timeline and if this is today, then the value that occurs today, right, is called the present value. Suppose my value is 100 rupees, so 100 rupees today is my present value. The value that occurs in some time in future, maybe fourth year, right, or fifth year, maybe this value is, say for example, 500 rupees. This is called future value. Cash flow are, these cash flows are called CT. Like this is at time 0, so I should write this cash flow. If I mention this cash flow, I should write C0. The cash flow that occurs at the end of year 1, I should write C1. The cash flow that occurs at the end of year 2, I should write C2. Annuity is equal stream of cash flow. If these cash flows are equal in all the years, suppose 100 this point, 100 this point, 100 this point, then this kind of equal stream of cash flows are called annuity. R is the rate of interest that we are applying for the problem that we deal with. So R may be any percentage, maybe 10%, 12%, 5%, any percentage rate of return that will be covering, right? So when I'm calculating the future value, right, I call this return as compounding rate. When I'm calculating from future value to present value, I call this return discounting rate. So that is the difference. So this 10% can be both compounding rate as well as discounting rate. If I'm calculating the future value, then I should call it a compounding rate. If I'm calculating present value, I should call it a discounting rate. And this N stands for the number of years, in this case 4 years, 5 years, 6 years. So this is number of year is N. Okay. So first we have discussed that we have 4 things to cover up, like future value of a single amount, present value of a single amount, future value of an annuity, present value of an annuity. Now we'll start off with very basic, right? So suppose we start off with the problem is a very basic problem, and the first one is the future value of a single amount. So while doing this problem, future value of a single amount, first imagine the timeline, right? So basically what I'm doing, I have a timeline here which starts from 0, and I have a timeline here which ends at some year, right? I have some value at point 0. I want to calculate some value in future. So suppose you deposit 1000 rupees today. The moment you get this 1000 rupees today, that means you know that 1000 rupees actually comes here, right? 1000 rupees today in a bank that pays you 10% interest compounded annually. So R equal to the interest rate equal to 10%, right, compounded annually. How much will you deposit? How much will the deposit grow after 8 years and 12 years? So suppose N equal to 8 years. N equal to 8 years, right? First we consider N equal to 8 years. So that means this is 1, this is 2, so and so forth, and it is going up to nth year, N equal to 8. Now how much this figure will go to? What is the formula? What we are calculating? We are calculating future value, right? So I must write future value, right, of a single amount. So this is same as what you have done in class 8, compound interest. You have certain principal into 1 plus capital R by 100 to the power n. So instead of principal, I write it is present value. What is your principal? What you deposit today. So what you have today, what you have invested today, that is your principal, that is your present value, right, into 1 plus your rate of interest R, right, whole to the power n. Okay, so if I just write it in this manner, so my future value will be equal to, what is my present value, 1000 rupees multiplied by 1 plus, this is small r, so 1 plus 10% means always we'll write 0.10, right, to the power n. N is 8. Clear? So if I calculate this figure, then that means 1000 into what I want to calculate, 1 plus 0.10 to the power 8. So if you have your calculator, you can calculate this 1 plus 0.10 to the power 8. The amount will be 2.144. 1.144, right? So if you calculate 1.10 to the power 8 in calculator, this amount will be 2.144. Alternatively, there is a table also, right, where you can get this calculation done. That means this particular calculation done. Now how to use that table? Let me see that. I have a table open here. Okay, so what table I have to refer to? I have to refer to a table which is called future value of an interest factor, FVIF table, right? Please remember, I have to refer to FVIF table. Okay, now in FVIF table, what I actually have to see here, I have to find out certain percentage for some years, right? So my calculation is I need to get 8 I need to get 10% for 8 years. Now see, here I have percentages and here I have number of years. In vertical column I have number of years, in horizontal I have percentages. So I need 8%, sorry, I need 10% and 8 years. So this is my number of years. If I go, so please refer, this is my number of years. If I'm going right hand side, I'm actually going towards interest rates, and see here this particular figure 2.144 is actually calculated. So how do I get 2.144? I actually, there is a matrix of number of years and percentage. I actually find out the point that I need 10%, 8 years. So 8 years, and I'm going to 10% column. It is already calculated 2.144, right? So 2.144 you can get, if you can check in calculator, you get the same value, 2.144. so what is my answer? My answer will be 2144, right? So how much this money will become after 12 years? So let me erase this a little bit. After 12 years, okay, so now this is okay, let me clean this all together, erase all. So after 12 years my n equal to 12, so that is the only change that I have, right? Otherwise my r equal to 10%, right? And my principal amount, that is present value, is 1000 rupees. Present value is 1000 rupees. Okay, so my formula remains same. My future value that I'm going to calculate here is equal to my present value into 1 plus r whole to the power n, that is equal to 1000 into 1 plus r is 0.10. Now in this case I need to the power 12, right? So that is equal to 1000, right, into, if I calculate, I'll get a value of 3.138, and my result will be 3138, right? If I go to the table also, I get the same thing, right? See, now I need 12 years, so this is my 10%. Now I need 12 years, so let me take the 12 years. So this is my 12-year figure, so 3.138, right? So this is what you can get by calculation also. This is what you can get from the table also. So this is how I calculate a simple future value. Now here we calculate the present value. Now here we calculate the present value, here we calculate the future value in a different manner, right? So let me complete that in the next video.